a large program in Colombia about energy systems. And this is our last webinar of this year that we've been working very tight with the University of Aachen. And we have a really special guest in this webinar. I'm really pleased that we will have some short presentation about the vision of the open data and the open source focus on energy. And we have three special guests, Dr. Simon Hodson, Dr. Shuli Goodman, and Professor Antonello Monti. And after the short presentation, we will have a discussion about the opportunities that we have with this open source and open data, and some questions from the audience. So let me just introduce our guests. I have I think a not accurate picture of Simon right now, but he's an executive director of CODATA, an expert of data policy issues and research data management. And he has contributed to influential reports on current best practice for research data management policies. So it's a pleasure to have you here, and thank you to accept our invitation. Please go ahead with your presentation, Dr. Simon. I will just remind, we will record these presentations and this webinar. And then we would like to, if our guests allowed us, to upload in the YouTube channel that we have, but just if you agree to that. But I think we are in open things, so probably yes. Okay.
Okay. Thank you very much, Ernesto. Yes, since the pandemic this year, I've grown a beard and grown my hair long, as lots of people have. But I assure you that if I shaved, I would still look something like that picture. It's not for so long ago. Thank you very much for the invitation. I'm not an expert in energy systems, but I do a lot of work on open science and fair data, and I understand that my role in this webinar is to present some current developments in those areas, which I hope will be informative when then we translate that to issues of energy systems. I work for CODATA. CODATA is the Committee on Data of the International Science Council. We're based here in Paris. We're more than a committee. We're an international expert community. We have working groups and task groups and a number of activities. 4 areas of activity in our strategy. We do a lot of work on data policies, significant report most years, do a lot of work on data science. We have a data science journal, regular conferences, and task groups and working groups on particular technical issues. We do a lot of work on data skills and data education, regular workshops and training activities, and we have strategic programs which we call Data to Improve Our World. And I'll mention one of those, which I think is of significance at the end of the presentation, but that's just a very quick overview of what we do. Now, this is a slide that I haven't used for some time, but I thought it might be useful as an introduction, given the topic or given the community that I'm speaking to. A few years ago, many years ago now, maybe about 10 years ago, there was a vogue to say, is data the new oil? And to argue that data could be the new oil. And let's be honest, in many respects, it was a hype term, it was marketing. But in that analogy, there is both a kernel of truth about the value of data, and there is something which is fundamentally wrong in the analogy. I'll explain that, and I think that helps us understand it as a useful way of introducing what we mean by open science and fair data. So the analogy works because the digital revolution, the transformation of our lives through ITCs, and in science and industry and research and innovation, the ability to create and analyze digital data is at least, if not more, transformative than the revolution due to carbon fuels and the Industrial Revolution. And there is a value chain whereby increased management, refinement, processing of data can increase its value. But there is a fundamental difference, which makes that analogy absolutely absurd, which is that data are not exhausted when they are used. The whole point of open data and open science is precisely this realization that, to use the economic term, data are a non-rivalrous good. My using data does not necessarily prevent someone else from using them and reusing them for the same purpose or for different purposes. And that was nicely expressed in this statement on open knowledge from George Bernard Shaw. If you have an apple and I have an apple and we exchange these apples, then we each still have one apple. But if you have an idea and I have an idea and we exchange these ideas, each of us will have two ideas. Now that's a nice quote, and it's a sort of a piece of old wisdom, if you like, from George Bernard Shaw, but it says something fundamental about the drivers of open data and open science, and I'll go on to explain that. Open science has been a significant movement and a growing movement for the transformation of science for a number of years. It recognizes that the revolution in IT, the revolution in data, and the revolution in communications has a transformative effect, not just on our daily lives, but also on the role of science, the communication of science, the reuse of data, and in ultimately the transformation and the potential transformation of our work. The organization that I work for, CODATA, is part of the International Science Council, and the mission of the International Science Council is to advance science as a global public good that has a transformative effect and that benefits humanity and the world. And there's an increasing recognition that open science and the methodologies and the technologies of open science are part of that transformation and are the way to achieve that global public good. Open science aims to maximize the benefit of science for society and the engagement of society with science by making the data, the argumentation, the processes upon which science rests as open as possible, and that as possible is important, improving transparency, improving the engagement with policy making, and improving the co-creation of knowledge, and also encouraging open innovation. This idea that there are benefits in pre-competitive sharing of knowledge, expertise, data. It aims to promote good practice and scientific reproducibility by maximizing access to robustly described data, the software, the code, the open source software, and the methods underpinning scientific conclusions. But important to emphasize, it does not mean unrestricted openness. Open science does not mean unrestricted openness. And there's the increasingly used mantra, if you like, or maxim, as open as possible and only as closed as necessary. There are significant developments this year and next year in the world of open science, if you like. UNESCO has conducted a survey internationally and has prepared a first draft of a recommendation, which we hope will be adopted by the UNESCO General Assembly in November 2021. That draft is available at that UNESCO ARC ID link there. I have the honour to be the Vice Chair of the expert committee, which has worked with the UNESCO Secretariat to produce that document. It's available, and UNESCO invites comment, critique, improvement by the end of this year at that email address. The recommendation proposes 7 areas of action: to promote a common understanding, to work on policy, to develop open science infrastructures, to invest in capacity building, and the necessary transformation of scientific culture to align with open science, to promote innovative approaches for open science, and to improve international cooperation. And I will also commend to this audience, I'm not going to go into a lot of detail in that recommendation beyond those categories of areas of recommendation, but I will commend to this audience also CODATA. As part of the process towards the development of that recommendation, we submitted a document called Open Science as a Global Transformation, which was collaboratively produced with a number of other data organizations, and we think is a relatively significant contribution to that debate. Now, I said I was going to talk about and introduce this idea of open science and some of the parameters of that, which I've done relatively quickly. I'll be happy to answer further questions on that. And also then to talk about FAIR. We often say fair data, but FAIR also applies to software and all the tools that support data. So the metadata profiles and the semantics, the controlled terminologies that make data work. And the FAIR principles are a neat encapsulation of those things which need to happen to the data and the surrounding supporting information objects in order to give data the greatest value it may have for reuse, ultimately. And so this is the idea that data should be findable, accessible, interoperable, and reusable. The FAIR principles, as I say, they're a minimalist set of principles. There's a lot of work to be done on how they're implemented, but they're an excellent guide and checklist for what we need to do, as I say, to give data the greatest value. I'm not going to go through that list, but hopefully that slide is useful, and there's a link there to the original article that presented these FAIR guiding principles. And that's an article that I think has been cited now something like 1,500 times. It's had a significant influence on our thinking about data. I had the honor to be the chair of a European Commission expert group which produced the report which you see on the screen, They're Turning FAIR into Reality, and that tried to make a contribution, I think did make a contribution towards that process of how do we take the FAIR principles and implement them in a broad science and science infrastructure system. And I think that report has some guidance, some lessons for any sector, energy, for example, which might want to increase the fairness of the data and the information tools that it uses. And it provides a guide and a roadmap to what does it mean to make things more findable, to make them more accessible, both for humans and machines, not necessarily open, and to make data more interoperable so that we can combine data sets from different sources, and to make data more reusable, essentially providing that contextual and provenance information so that it can be reused more effectively by humans and programmatically by machines. Now, I want to make a clear distinction between fair and open. They're distinct but complementary ideas. Data that is fair does not necessarily and does not have to be open. One of the drivers of FAIR, it's true, was that the call for open data meant that people were dumping data on the web with insufficient documentation and insufficient supporting information such that it could be interoperable and reusable. And so FAIR came from this response to that, saying we need principles to ensure that the data is usable. Raw data is not necessarily of use to us. But one of the important things to remember about FAIR, I think, is that FAIR is a very useful set of concepts and guide because it applies as much to data that must be restricted for privacy reasons, for other issues of sensitivity, for commercial reasons, as data that can be open. So commercial organizations, for example, it is in the interest of a commercial organization to make its internal data fair within the organization prior to open sharing of data. And that's an important thing to recognize. So to reap the benefits of ICTs in this global transformation, we need fair data, and we need to invest in data. Above all, complex systems require getting data from many different sources to work together, and that emphasizes the I and the R of FAIR, the interoperability, how we combine data, how we make different measurements commensurable, and how we reuse data, having the provenance information, as I've said, to understand where the data came from and how it can be processed. We need to consider data as an infrastructure and as a service, and for maximum benefit, it should be as open as possible and only as closed as necessary. So I'll close, if I may, this presentation by talking on 2 slides about an initiative that CODATA is undertaking to address our ability, to improve our ability to combine data in cross-domain grand challenge research areas. And that's a set of work which I think may have implications for this sector, for the energy sector, and with which in the future perhaps we might collaborate. So, as I've said, our parent organization, the International Science Council, has as its mission advancing science as a global public good, and created in 2018, 2019 an action plan, and you can see the cover there. Part of that action plan was a task which was entrusted to CODATA to improve the way that we can use and combine data, which is fundamental for cross-domain grand challenges. When I say cross-domain grand challenges, I'm thinking of things like climate change, mitigation and adaptation, the growth and the resilience and health of cities, on disaster risk. These sort of grand challenge global research issues, which are aligned to the UN's 2030 agenda. So also the Sustainable Development Goals and the send-out process. Each of those research and policy areas require input from research and science and data from many different sources. And they're excellent test cases for precisely the objectives of the FAIR principles. How do we combine data from different sources? How do we make data interoperable and reusable? So addressing global challenges requires cross-domain collaboration. And it's a major challenge. Much work in those areas is hamstrung, is delayed, or has as significant obstacles the need to process and combine data, to manage the data, to clean the data which is obtained, and the challenge of combining those data. There's a report, and I didn't put this statistic on this slide, but there was a report a couple of years ago from PwC for the European Commission, which estimated 80% of project effort, 80%, was expended on data wrangling, obtaining data, cleaning the data, and manipulating it such that it could be combined. So it's a major challenge, and the International Science Council has entrusted CODATA to prepare a program to support those international activities by trying to help address those issues around good practice of data such that we can combine data more effectively. Final slide on this, really to emphasize when we're talking about fair data, the sort of things we need to bear in mind to implement. Vocabularies, community vocabularies and terminologies which provide clear definitions of the things we have measured. Rich metadata, and we're doing work on what we call fair implementation profiles, which is understanding how particular communities, the sort of information that they need, and the sort of standards and specifications that they use when describing their data. And we're working with the Data Documentation Initiative, which produces social science data profiles, metadata schema, on a new product called Cross-Domain Integration, DDI-CDI, which is designed to look at data in an abstract sense and to assist machine processing of multiple data sets. That's work in progress, but we think with those 3 areas of activity, we can those 3 areas of activity will be at the heart of this, the program we've been asked to develop, and we think will be of use to particular research areas and cross-domain areas, and perhaps to sectors such as the energy sector. There's more information about all those activities at the forthcoming FAIR Convergence Symposium It's free to attend, so please come along, please register, and there'll be a lot of sessions on that about FAIR, about how we're developing the concepts and how we're implementing FAIR in various research domains and various research projects. So I hope that might be of interest. And there's quite a significant participation from a number of sectors of industry, including the pharmaceuticals, and there may be work there of interest to the energy sector. Thank you very much for your attention.
Thank you, Dr. Hodson, for interesting presentation, and it brings for our next presentation that is related with open source. But now the open data, I think, is the most significant part to make other things happen, as we mentioned. So thank you very much. We will later, after the two presentations remaining, we'll go to some questions and a discussion of the subject. I would like just to introduce, I'd like to introduce Dr. Shuli Goodman. She's a co-founder and executive director of Linux Foundation Energy. She has a PhD on organizational systems and sustainability. She has been leading initiative to empower collaborative work, especially this in the energy sector with this Linux Foundation. So Dr. Goodman, Shuli Goodman, thank you very much to be here. And it's a pleasure just to hear you in your presentation. Thank you very much.
I think that I think this conversation itself is exemplar of the process of transformation that the energy sector is going to go through. Simon, I am so happy to hear you, and I have a group I really want to introduce you to, which is my data architecture infrastructure. And so we've been talking about FAIR, and they meet every Thursday, an hour before this. And so I want to make sure that I introduce you to them and that you come and present, because you will be talking to a community of people who are completely pulling in the same direction as what you are describing. What's remarkable and what makes me incredibly hopeful, Ernesto, is that a convening in Colombia can connect us in South America, in parts of Europe together in a common conversation. And in some ways, because of COVID, this is possible. In COVID, we'd all be flying around. Instead, we're kind of sitting in our seats and available. And so I think when I ask people to think forward, imagine 10 years, 20 years, 30 years from now, and I ask you about what the world was like in 1990, or 2000, and the way in which, when we were about the internet, we had an imagination that this sort of could happen, but we did not have technical capacity, the infrastructure models in place to make it happen. And so in many ways, what we're doing here, imagining the future. And in imagining the future, we really need everybody engaged in that. So I think that the driver of decarbonization is accelerating into a period of chaos and kind of dissolution. And I don't think that that's a bad thing. I'm a landscaper, a gardener, and I know that my compost pile is one of the most important parts of what I do. So I want to just thank everybody, and I want you a good morning, and I am very happy to be talking to Colombia with someone in Paris and someone in Aachen. And Anto is an old friend of we have found common cause. I'm hoping with Simon that cause too. So this is what I think is really going on now. We have got an unbelievable logjam. And I think that all of us are trying to figure out how do you actually unblock this logjam. Utilities are fundamentally not rewarded for innovation. They are not rewarded to move at the speed of technology. And some of that is, based on the systems themselves and the role of inertia in balancing supply and demand. But some of it is, just kind of this constellation of, fossil fuel producers, utilities, regulators, our, economies. It's a very complex problem. So the reason why I show you this and that I want to start my talk off with this is that you do not break up a log jam by delicately picking at a log, trying to remove one log, make the log jam to make the river flow. Actually, what we don't have a lot of log jams in 2020 in reality because we have logged so many world's forests. But past, what they would throw a stick of dynamite on and it would move. And I believe in some ways, open source is that stick of dynamite. It has less regard than it does for action with regards to the future. And when I think the grand challenge that's in front of us, I to 75 because I think it's really hard exactly, but when we remove carbon from the grid, from the built environment, from transportation, we really are removing a substantial part of the carbon that enters into our environment. And that invisible pollution, invisible externality is what we have to remove. And as somebody who lives someplace where we have had fires years in a row, and I have had fires breathing down my back since August. The idea that if we're 1 degrees, I don't want to know what 2 degrees. So I really want us quickly, and so really from that perspective, that I went to the Linux Foundation and talked with them about using that platform, that competitive platform. Simon, I loved that you naming it as pre-competitive because for kinds of economic transformation that we need to go through, we need to create environments where there can be pre-competitive collaboration to create the future. And really what we're doing is we're creating the future in much the same way that in 1997 we might have thought about this particular conference call that would happen with people from all over the world, but we really didn't know we were going to get there. So this is what L is. What I want to take a minute to talk about because energy transition is a social, technical, and economic event. And I think that the social part is not talked to enough. But I think it's critical to talk to it and to understand where we are in this diffusion process. So, the typical diffusion curve. And there are exceptions. Color TVs were an exception. Cell phones were an exception. There are innovations that profoundly, that people say I want, and we have these straight up and down curves. Energy. I don't know that the energy transition has that same kind of compelling thing like I want a color TV or I want an iPhone. But this is what the challenge of decarbonization, this is what the adoption rate is. We have to go essentially, this is a 9% annual kind of diffusion. Say that really, if we're waiting around for 2050, we're going to be in a lot of trouble. I actually think that we need to get a lot substantively this transition to consider movement within the next 10 to 15 years. And so the kind of transformation that we're going to have is going to what the energy than what has happened with energy for the last 104 years. So when I think about that, and I will give you all the link, but I want to get to someplace. I'm through all the slides, but the bottom line is that isolation and alone are no longer viable. So we have to come up with a different model. Yet we have utopias that lumber along and with creative interventions in order to be able to get us to move at the speed of technology, and to do this with collaboration. And that's the reason why I believe that the Linux Foundation is particularly to creating the future that we want to see. The Linux Foundation, if you don't know, it's kind of one of the big secrets of the world. It's the home of the Linux kernel. It is also the home of 420 other projects, including one of Anto's projects that just got adopted last week. And these are the most important open source projects on the planet. And where I sit, open source really is a property license that enables and allows for collaboration. You can have no property is going to be lost. And that's what the Linux Foundation does. And we're about 250 people. And what we do is we're like gardeners, really, in that we the ecosystems that enable 5G, that enable automotive grade Linux, that enable cloud native computing to go from an idea to ubiquitous. And, I'll put this in and you can kind of look through it and see what the talking points then are. I do want to point to when diffusion perspective, where energy is going. Sometimes it's important to be able to look at other industries and to see what. And I think one of the most kind of contributors or indications of the direction that we're going in really has to do with what happened with 5G. And with 5G, you had a company, AT&T, communications company, who essentially recognized they needed to move to 75% virtualization. And they got about 25% of the way there and then realized they were not going to make it. That they've done so far into the organization. And within that context, they were able to really reduce deployment from 6 months to 15 minutes. They really began moving at the speed of change and in terms of virtualization. And the vision underlies the diffusion example of what happened in communication is that they had black boxes of which energy systems are neutral, and had market disruption. And the first kind of process of disruption is around disaggregation, the ability to separate hardware from software, and to create software-defined infrastructure. And that is the benefit of open source. That is not a proprietary event. It's more like when you are building a highway or something. You don't want that to be proprietary. You want that to be part of the infrastructure that enables goods and services to move. And in the same way with energy, what we want to be able to do is provide a software-defined infrastructure that will enable automation and virtual functions. And Simon was, which is the currency for all of this is data, and it's being able to move data from the edge into some kind of an orchestration control environment, and then out to the gateway to customers. And while there will be many, many people, and I think that there are choices that people have around the world that are not the same as what is happening in Western countries where there's been an investment in infrastructure, there's also room within this for distributed infrastructure. And so that recognition of centralized and decentralized, localized, moving at milliseconds to moving at minutes, that distributed versus centralized is kind of at the core of the paradigm shift that's. So, a couple of years ago, the architects, a group of about 20, got to begin really define what they believe the future grid look like. And why I want to show this is because I think when we begin to look at the taxonomy of the grid of the future, what we are actually talking about is a microservices view of the grid. And I say this often to folks. There is no place on the planet where there are 1,000 engineers in a basement building the future who are going to work for 10 years on this and then throw it over and we are going to convert. There are no more forklifts. Being able to understand what functional architecture looks like is really one of the first steps towards really imagining a distributed computing paradigm, driving and engaging and supporting a distributed energy paradigm. So these were the 5 blocks at the top that they broke the grid down into. I'm going through this really quickly because I want Anto to have plenty of time to talk. This is the next level down, and then this is where we actually get to. These are the microservices, and so what we're doing really is beginning to build the core components that are going to enable architecture to come to. Our goal is to utilize capital. It is not to destroy the vendor's opportunity to be able to work. We want this to be, an innovation tsunami. But I think that having a common vision of the direction that we're going in is going to be quite critical to ensuring that we are, kind of in a consort of way. Our projects and working groups that we have happening right now. And if you go to our website, if you go to lfenergy.org, you can find out more about each one of these projects. And then you can also go to Wiki and get involved and join them. The final thing that I'll say, started working on the functional architecture, it also became clear that there were 3 other frameworks that we needed to be working on. And this is where, Simon, it would be great to team up with you. So there's the functional architecture and how we support and manage that so that across high, medium, and low voltage, we have a common view of the universe. And say that the way that this architecture will pose itself is what a grid is. It is what a nanogrid is. There are parts of these things. So I think that hierarchies or the silos, part of what this architecture begins to do is solve those hierarchies. And it's kind of the dynamite that we need in order to get things moving. But kind of to close, the data architecture, how are we going to really cloud native? If we're describing is cloud native architecture, how does it work? How do we work with the latency? What is the interaction relationship with 5G? All of these things are essential because the convergence between 5G, cloud, energy, and automotive is certain. And so I love BI cross-domain integration that Simon mentioned because that is precisely what is happening with energy. And so in that way, the fact that we are on a call using the internet, being able to see each other in different places in the world is kind of an object lesson in levels of transformation are going to happen in energy in the next 10 to 15 years. Thank you for your time.
Thank you, Shuli, for your presentation. It's very, very interesting. All the opportunities that we have and the link that we can have with the data. And we'll have later a discussion with that. Also, we have some participants from Latin America, also Peru and Ecuador. So yes, we were able to link a lot of people here from different regions. And this the most interesting thing that we have. The first thing before the COVID, we organized this as in presence, but I think we couldn't have what we have done up to now. We have been in several webinars and we link a lot of people from different countries, and I think we have a great opportunity. So thank you, Shuli, for sharing with us these comments of the open source. So finally, this short presentation, I would like to go with Professor Antonello Monti. So some of you have been here. Professor Antonello Monti has been in all the webinars that we have done up to now. And he's just really short thing. So Professor Antonello Monti, he's the director of, he is part of the Institute of the Automation Complex Power Systems, and he also in University of Aachen, and he also participated in Fraunhofer, the Center of Digital Energy, and he has a lot of experience implementing things in open source. So thank you, Antonello, to being here again, and I give you the word.
Thank you. Can you see my slides?
Yes, we can.
Thank you very much for inviting me to speak this evening. For me, it's evening. For you, it's morning. And it's a pleasure after two fantastic talks to have the chance as well to tell a bit about my experience. And what I want to do is to give a brief overview on this role of open source in the process of digitalization, with a special reference to the transition in the energy systems, the way we are managing, let me say, in Europe, and then particularly the relation between research activities and the European Commission in driving this process. What is very important to mention is, since 1 year, the energy transition is not just a promise, but is a law in Europe. So with the new commission in place, with Ms. van der Leyen leading the new European Commission, she put as a first action this commission to transform all the generic policies on energy transformation in a real law. So that now is not anymore a discussion, that Europe has to turn around the energy system with clear target from now to 2030. And actually, in the last few months, the target has been raised for 2030, and then going all the way to 2050 for a full decarbonization. This has been a fundamental change in the environment in Europe. And this means that we have the digitalization on top. So the energy system is transforming itself and has been an energy system in a quite quiet sector, I would say, for about 100 years. And the upcoming of renewable energy systems and this transformation, decarbonization, comes together with the chance and the opportunity, but also the challenges to get into a digitalization process. So basically every sector is facing digitalization, and that's a revolution per se. But we have a revolution in the revolution in the energy sector, and this is a double shock. And there's maybe this dynamite Shuli was mentioning that could really shock the energy system to a fast pace. But what is important is that when we look at the energy system, and was mentioned before in the presentation, and that is not only a technical problem. So we are not just trying to substitute a bunch of power plants with new power plants, but we are completely transforming the energy systems with clear impact from a social perspective. In another document, the European Commission that was released 2 years ago, called Clean Energy Package for All Europeans. This for all Europeans was not just something to make the title a little bit longer, but was the intention to transform, again, the energy system to put the customers at the center. So if you look at the utility as the way I've been operating for roughly 100 years, the model was very simple. There was large generation, there were kind of money machines, and then some customer at the end was simply consuming and paying a bill. Now, with the move of the generation out of the large power plants and the consumer more and more in charge of their own generation, the customer is not anymore a customer, it becomes an active player in the energy systems. And then we need to restart from the bottom to rebuild the systems and aggregate in the system to be able to have the same quality of service that we had in the past. So because the challenge is that the energy system has been extremely reliable, particularly in Central Europe. So how we build a system from the bottom that is as reliable as before, but is more based on customer involvement, interactions, and a huge number of players. This would not be possible without digitalization. And that's why digitalization is in the middle, is an enabler and is something solving and enabling not only a technical element, but also a social component. But we need a lot of ingredients to make it work. And then if you look at the electricity sector, and then we will expand to energy, and we have to think the first key element is data models. If we look at data models, the electricity sector has been quite advanced in that respect. We have standard developed at worldwide level, thanks to activities starting from IEEE, then going to IEC. This process has been in place for a while. And let's say the electrical engineers understand data models. Even if the digitalization was not that strong in the past, data models have been clear for a long time. But then we need architecture to use this data. And when you look at architecture to be transformed in the energy system, the face is not as happy as before. Why? It's not that we don't have ideas, but we don't have a convergence of ideas. There are huge number of solutions, but one of the major limitations, and that's where we start going in this direction, why open source, has been that everybody has been developing their own closed solution, and then we don't have the possibility to build something that could be considered like the European energy system. We don't have a lot of business models in this new version. So particularly when you talk about customer-centered grids, so bringing the customer at the center, yeah, there are ideas, but still we are far away from a large adoption so that this machine is really unlocked to make the process possible. And we have governance, because it was discussed before, we start having something based on data, also private data, and who is going to orchestrate this complex machine of data transfer and data management? What are the governance rules are still something in progress. And the other, last but not least, is we want to start decarbonizing the electricity systems, but in the end, we want to decarbonize the energy system. So we don't go beyond the electricity network. And then we need sector coupling, because the electricity will need huge level of flexibility And this flexibility cannot be found directly inside the electrical systems, but it only comes from the interaction from other infrastructure. And it will come also because of data that comes from completely different source of information that will make that possible. And here we are still in the infancy as well. So if we don't solve all these 5 red things, and like I say, we are good basically only in one, if not 100% ready, that shows how the process is complex. But that's where also we can link immediately to the role and importance in open source. So I'll come back to this probably more than one time in the presentation. Nobody can solve this alone. This is basically what Shuli was saying. Nobody can think to come with an architecture and sell it all over the world and everybody will adopt it. Nobody can think to define alone the governance. Nobody can solve sector coupling alone. It's only by cooperation and transparency in the cooperation that we can do something to make this agenda possible. And that's the key point. And that's where, at the end, we see that open source is a key element. I can give a very simple thing. So if we start with interoperability, this has been the common topic in, I don't know how many research projects in European level. And everybody is saying, I'm achieving interoperability. Normally people talk about interoperability of data. And that's already something. We have data models, as I say, this is okay. But what we need is also data exchange. That's a little bit more complex. And immediately we start having an issue because solutions are built for a specific communication media, for a specific protocols, and even at the same type of data flying through, we don't have interoperability at that point. But things are even more complex in a full digital world because we need interoperability of services. If you build new business models, we don't exchange data for the sake of data, but because those data unlock and activate services. And here we have a significant work to be done. And that means that all this pyramid of challenges and interoperability will have some consequences. The first one is because we have customer at the center, as we said, a key important element under constructions is data sovereignty and privacy. Those are stated in law, particularly in Europe with the GDPR. We've been doing a very important step in protecting customers from a data perspective. But if the customer has to participate, we cannot go in a direction to simply lock in the customers. And so we need solutions for that. There are some emerging aspects and proposals in Europe, particularly the work done by the International Data Space Association is getting a lot of resonance and looks like an emerging candidate to do this. And the other is sector coupling across domain. As I mentioned before, we can solve the energy or the electricity, but only if we go across and we break the silos among the different sectors so that we don't look only at electricity, we don't look at energy, but we look at the whole options opened by digitalization in other sectors. So the fact that digitalization happens everywhere is actually an opportunity, but we need to be able to use it. And in this domain, in Europe, one of the key winners to try to provide a solution to interoperability among sectors have been the development of fiber as solutions to move from one sector to another, thanks to some standard building block approved by the European Commission as European standard for the Common European Facility Program. In particular, the so-called context broker, which is a piece of software, allows this traffic of data among different sectors. But if I want to build a picture in the electricity domain, I can try to oversimplify the challenges to give an idea on how and where are the problems. The problem is that if we have this bidirectional flow of energy, we have a bidirectional flow of data, which means that we simplifying in a way that most electrical engineers will kill me and saying that there is a TSO level, so transmission, so long distance energy transmission, DSO, local energy management, and customers as the 3 layers. We have to make possible the data transfer among those, and we have that level of interoperability of service that was mentioned before at all these levels and among all these levels. That means there is a huge effort to be done, and there is the need to bring efforts together. In Europe, we have right now a set of projects that are trying to build these pictures, and there is a very good synergy at the transmission level because all the transmission system operators work together. So they are their own community, which is already a good step because there is cooperation among all the 27 countries, and they have their own program of digital activity, which is bringing very important fundamentals to be coherent. But we cannot stop there. And when we started the interfaces, we have two projects right now, one more focused on the TSO perspective called interface, and one called coordinate, which is trying to solve those interface points in a reasonable way and coming with common architectures and common protocol for data exchange. But we have a key challenge, which is the distribution system operator are the one that are facing digitalization in the real way. TSO, at least in Europe, are already quite digital for quite some time. The transmission level is smart. When I heard the word, I always start my class saying that I don't like the word smart grid because it looks like we have a dumb one. The grid is smart if we can run 27 countries fully synchronized in Europe with no major blackout ever happen. Something smart is there, and that's what the TSO has been doing. But the DSO are the new one. And the bad news is that we have much more infrastructure at the DSO level than TSO. So even if it looks like we have done a great job, it was just scratching the surface because the real long kilometers line at the end are in the local network to reach every single house of every single citizen in Europe. And here we have some key projects that are trying to address those challenges to bring the DSO to another level so that can be as digital, at least as the TSO. And then we need to bring the customers. We need to find a way for the right interface between grid and customer. And that's already we have some in running project. But this is again a constellation. And what we are trying to do now in the new project just started, I have the pleasure, the honor to coordinate called OneNet, is to really bring this effort. There have been 6-7 years and hundreds of millions of euro investment or research to create the constellation of solutions, but they're all parts, not a system. And that's what we aim to achieve in 3 years with the project OneNet, so that we can really give one electrical network for Europe. And this will be really the task to align all those ideas, basically, of architecture and so on, emerging from the different projects I mentioned, all of them contributing, but no one having the strengths and to bring everything together. Now, I'll try to give you some examples. What we've been disrupting doing in this type of digitalization exercise is to come with completely new architecture that we're not used at all in energy. A microservice-based approach to distribution grid automation was introduced in the project Sonio and has been really a disruptive view. Disruptive because it allows to open up the system while before we had legacy system very much closed, not open to innovation, and they were moving too slowly. And with this project, we have been demonstrating that it's possible to do it in a different way. We can exploit modern infrastructure. Shuli was saying 5G, the Sonio concept can fully run on the edge of the 5G network. Not by chance, our coordinator was Ericsson, and same time be compatible with the philosophy of a control room in the classical grid operation. This has been a first step. And as mentioned, Sonio, as it's its own architecture, as Shuli say, I'm really proud to say that being accepted as the Linux Foundation project just recently, and now we are creating a community around that, taking the results of a research project, we'll create a community around, so we all together work because we need a huge number of services developed at the right level. Nobody can do this alone. And if some company think I'm going to build this, they're going to fail, and there is no way out. But what is critical here is what is disruptive is that we move from a SCADA-based architecture, which everything is closed, to a multi-vendor service procurement in which an open architecture allow rapid innovation to enter in the automation at completely different pace. This is critical because while this penetration renewable grows and grows faster and faster, we need the grid automation to keep up. I just was talking to a grid operator that I will not mention, and they are facing, they know because their prediction on how it's changing their load, particularly related to electromobility, is supposed to be the biggest challenge on the grid in Europe, in a city. And when I talked to them about this view, they told me, look, we need this right now, because when we went to the manufacturer, Classical, to tell them the complexity, they told us they will not deliver on time. But we have no chance because this is happening. This is where it's not anymore, as Shuli would say, it's not an option, it's the only way, because we don't keep up with the rhythm if we don't do it together in a collaborative way. And that logic has been already selected by other projects. This is another project where putting this DSO technical platform, so the Sonio idea in the center, linking to legacy systems, opening up to market. This is the key point that now the customers that are here in the picture at the bottom can enter the system. This is, Sonio was developing the automation, so the Sonio project opened up the automation for DSOs. Now, from that idea, with that architecture, having that architecture, we can bring the customers in. And the idea is to bring them in through a blockchain interface that bring the data in a secure data bus that can be also used to link for operation while supporting market services. So that in principle, in this vision, every customer in every location in Europe can enter the system, participate to market in a fair way. And as I say, then we want to bring all those efforts together in the OneNet project that I mentioned before, in which we hope to really align an incredible number of projects that happened in the past. It's a huge, I have 72 companies working together to make this possible in 3 years. And again, there is immediately the agreement from day one, it's an open source project. I put it in the grant agreement, it's a contract with the European Commission. People cannot work in this project thinking I'm gonna do my stuff and I just hold it on in an old mentality. And we're not just playing in the lab. So when I say these are research projects, you don't have to think about a couple of crazy engineers in a university lab. We are talking about real grids. In the OneNet project, we have defined 4 large demonstrations going across basically the majority of European countries. So we organize them in clusters, you see here. Each cluster will test new market concept connected to automation that will facilitate what we call multi-multi scenario. So TSO can exchange with TSO, DSO to DSO, DSO to TSO, country to country. Everything is possible because we have one net for Europe. And we will try with clusters as a first, which is already a multinational demonstration logic. That's how you get to have 72 partners. And as a first large deployment of the technology. And basically, it's such a massive effort that 50% of our budget in going in testing the ideas, because we don't want to develop a lot of new things, but we want to align solutions and try if they really can work together. That's why those demos are very important. And then we are open as a project. It's not only an open source project, as key point here for the discussion today, but we will add partners during the project with an open call, thanks to cascading funds. And also, whatever we learn, we will put in open documents that we manage in an open forum that we will call Griffon, so Grid Forum, because the idea is that everything we learn, we want to distribute, get feedback from everybody, not only the people directly funded from the project, so that at the end we have a set of policy documents we can take, deliver to the European Commission and say, this has been not results of already 72 partners, but 200, 300 stakeholders in Europe that agree this is the way that we move from testing to deployment in a large scale. And, the common denominator of all this has been the culture of open source. That's what LF Energy is about. That's what I mentioned was Fiverr already as another initiative, more looking at these data silos, not energy per se. But what is interesting is that I learned a lot being involved in the research project Fiverr when it was a program of the European Commission, because the European Commission was pushing this philosophy. We had 3 phases in 3 steps. After the first phase, some of the large companies stepped out thinking, I don't understand why I should be doing a project about open source. And the Commission didn't stop, push forward to phase 2, phase 3. We created then a community around Fiverr. And now some of those big players are coming back and say, oops, I should have stayed in that community, because even companies that before were not understanding what is critical about all this open source movement, they understand now that is, as you Shuli say, not an alternative, just the only option. Let me close saying, I try to give an idea why I consider digitalization for the energy as a revolution in the revolution. I gave you an overview very quickly to give an idea of the complexity on what are all the points from which we are addressing these questions in the European Union. And there are completely new business models, mostly built with the mind that our customer is at the center. But nothing will be possible without an openness, because this is the key element for the fast digitalization. Thank you for your attention, and now I'm open for the second part of discussion. Thank you very much.
Thank you, Antonello, for your very nice presentation. Now we will open to a discussion and some questions from the audience. And we will start with one from Jairo Espinosa. He's asking this, what is the importance of public funding of their initiatives? Can these initiatives work as private consortium initiatives? Is for our 3 guests. So we repeat it. What is the importance of public funding on these initiatives, so the open data and open source initiatives?
Is a member-driven organization. And, we work with the principles that you would find in an open source project, which is that the code is freely available. You can go on our website, you can get a link to, right away just to get the code, and you can start working with it. I have not cracked the nut on actually getting public money, and I think the reason why is because I'm so mixed about it. Part of what makes the Linux Foundation work, neutrality, that there's no one player who has any, that nobody's put in $2 million or $5 million, and therefore they get a say in the outcome. It's a duocracy. Meaning that if you do well, you're going to have, you're going to be recognized. So in that way, I actually really like running community that way. Anto, who's a member, Aachen, which is a member that, they receive funds. So but we are a member-driven organization, and I think what we're talking about is placing a bet on the future. That the future is going to require competitive cooperation and coordination in order to be able to fake it for where we are right now. But another couple of years, it's going to be impossible to get to 90% decarbonization without, massive cooperation. So that's what I'm in it for. Sort of the two things I think about.
Yeah, I totally subscribe what Shuli just said. So that's the reason why we, at the end, developed this concept in one project. We are trying to use it also in real life projects now. But we need a community to work around that, or we'll be sitting in some GitLab and will be forgotten in a couple of years. And we as university have no way to commercialize or anything. It's not our job. So the best way for us is to keep the project alive, and that's exactly what it can happen in a community like we have in the Linux Foundation. That's why we took our work and say, yeah, can we make a project out of it? And now we're trying to bring as many utilities and companies in the sector in so that we all work together and we make it as big as it could. Because, of course, we didn't solve everything in one research project. But we built some ideas, we developed some concepts that make an inspiration on how things should be structured. And then the contribution will bring to be, something bigger and closer to an industrial product.
If I can come in on this one as well. In terms of the influence of public funding and private or charitable funding in the area of open science, which I was talking about, it really needs to be broken down. There's no doubt that in the end, there's been quite a big influence from public funders. The European Commission, G7, have made policy statements which have ultimately had significant influence. But in the areas of data sharing and other areas of open science like open access, there was some resistance from the academic communities, particularly in terms of open access to research articles, and to some extent in terms of data sharing, data access as well. I've got a set of slides that I use sometimes from a project that we were engaged with looking at Ebola, and a survey which was conducted by the Wellcome Trust, which looked at the availability of data that had been gathered by international organizations, NGOs, and universities in the global north, particularly in Europe and North America, and had been used to publish articles, and whether those data, which were essential to understanding the Ebola outbreak of 2012 to 2014, where those data were and whether they could be accessed. And they weren't being shared. They were on hard drives or computer systems in North American or European universities, and they couldn't be accessed by people on the ground or other researchers or policymakers who might want to respond to that outbreak. And it's outrageous, to be frank. That survey was used in part by the Wellcome Trust to coordinate with health funders globally to increase and to pressure for data sharing in that particular domain. And a lot of that pressure to change policies around, if you receive a grant, then you have to publish open access, and you have to make the data as available as possible. There may be some restrictions for privacy. A lot of the pressure has actually come from the charitable funders, from Médecins Sans Frontières, from Bill and Melinda Gates Foundation, from the Wellcome Trust. And the public funders have been relatively slow to catch up because they're more influenced, if you like, by their academic oversight boards and which are a voice for the resistance in the university system to open access and to data sharing. That's just one example.
Thank you for
Can I build on what Simon just said? Because this is a very important issue, which is recommendations that that we just made, the Department of Energy and the incoming Biden administration, is the need to create an open source program office. And that, so part of the problem is not only digitalization not completely understood, and it's my belief that at least 50% of the effort, you were talking about the amount of effort related to data. I think 50% of the effort is really going to be around networking all of these assets and networking our supply and demand, and that it is a heavy digital lift. The good news is that that abstraction of complexity, once you've done it, is actually extremely inexpensive to diffuse. And so, you know, I think that we're looking at how do you actually create something out of nothing, you know, like a project like OneNet. And then how do you diffuse that technology in order to ensure its adoption and its transformation of the marketplace? And what I have found in a very frustrating, I feel like I'm making headway with Europe and the Europe understanding of open sources. You know, they may not understand all the flavors of it or the implications of it, but there's a much greater understanding about licensing, open source, the role of data, that can lead to being able to submit Swanyo into the Linux Foundation. So, United States, very problematic for me. Where people will say, well, we can't give you the keys to the GitHub. And the Linux Foundation doesn't take possession of the GitHub, but it definitely needs to have the keys and it needs to have the trademark assignment, because otherwise it is not a free and open collaboration. And that makes building commercialization on top of it impossible. So I think that it's not so much that we directly but that it's important that funding that is put into research development, particularly at the university level, is done in a way that can be scaled. And that is really the thoughtfulness related to commercialization and diffusion has to be embedded from the beginning in terms of the licensing and the capacity to turn something over to a foundation that can scale it.
On the other hand, I would like to say that there is, I guess, what we can call still a big cultural problem. I've been in 2 workshops in 2 days recently, and 2 times heard a statement about open source that were completely crazy. The first time was somebody claiming, oh, yeah, I understand you work with open source because you're just an academic. And I said, what do you mean? You know, that's not the idea. The second, today, again in a workshop, somebody say, oh, you all guys are talking about open source, so there is no business model. Said, what? So there is still a lot of education to be done about what we are talking about, what is the view behind that. Even people that have kind of, I mean, responsible positions don't understand what's at stake here and what we are trying to achieve.
Yeah.
Technical books really lays the foundation is Thomas Friedman's book, Thank You for Being Late. And in it, he talks about kind of the evolution and revolution of open source. In other words, most of we wouldn't be having this call if it wasn't for open source. You wouldn't be using your phones if it wasn't for open source. Soon you will not be driving cars if it wasn't for open source. And you will not be getting electricity without open source, even though 100% all digital applications, energy have source inside. There is a very limited understanding about its role in That is going to have to change, though, because the security of the grid, regardless of whether it is a kind of distributed islanded grid or it is, a kind of DSO, TSO model of the grid, in order to secure that grid, the transparency of the software is going to have to become essential. And that is going to mean that, utilities and energy providers are going to have to learn to optimize the digital supply chain within energy. And so that's going to safe.
Simon.
Just to build on that as well, whether we're talking about open source software, open data, open access, and these various open components of open science, which can be applied to both research in the research domain and to industry, one of the things that needs to be addressed, and really to build on and reiterate what Shuli said, is challenging some of the misinformation, informing people, because I think there is misinformation, and interested, in the proper sense of the term, misinformation. But also demonstrating the viability of business models for open source and the economy that can build on open source, of demonstrating the business models for those service providers that provide access to open access resources or open data. It is this study of non-rivalrous goods and this study of pre-competitive openness and collaboration. We did some work, CODATA did some work a couple of years ago with the OECD, surveying data repositories in the academic world, well, not just the academic world actually, but those organizations that look after data in the long term, and looking at their business models. Now, they're increasingly, they need to provide the data open access, free at the point of use, and therefore what business models could they generate in order to do that? Now, for sure, some of this, a significant part of this depends upon public funding. But we wanted to explore the different models for providing that public funding, and we can be innovative in the way that we do that. And we wanted to survey, when we did survey, the research that has been done to demonstrate the economic impact and the return on investment for precisely that pre-competitive provision of data and knowledge. That case has been made amply, and yet it seems that we still need to make that case, and we still need to have those policy arguments about the ultimate economic impact and benefit of open source, open data, open access. And it seems to be, a frustratingly long fight. And if one surveys the literature, there's an awful lot of evidence in terms of public sector information, surveys, etc., for the economic benefits of that pre-competitive sharing. But the argument still needs to be made.
Thank you. I would like just to add something. I think we are working in a project. Also, this invitation is because we are dealing with a large project. I think the largest project that in Colombia is being developed in energy. And despite we have, I think, a good amount of money for that, we lack of money to buy a lot of commercial software, for example. So most of our research is just funded in open source software. And I think it's really, really useful for us just to find new things, because otherwise we'll be not able to do that. And I see that there are some other business models that can be made because there is open data and open source, because new people can think new things. So probably when we are in a company, we just have we are molded to a mind thinking. So probably when we have other people who think differently, they can see new things and be new business models. And there is a lot of experience in business model for open source. So even the software that we are using right now, this open source, they have also the commercial part. So if you want to have some commercial thing, you can pay for that, and you can have the service to maintain on all this stuff. So there's a lot of things that is really very interesting with the open source. But I would like to ask you something. We have a lot of issues, especially with the users want to use open source, especially in the electrical industry. We were talking with some of our colleagues in XM, that is one of the independent system operator of Colombia, and they refuse to use open source. So the IT directives, they don't want to use open source. Because sometimes they think it could be unsecure or unstable or have many other things. So what do you think we can do to make the user, industrial user, to have open source to be in their industry? Sorry, Shuli, it's mute.
You know, there are 25 million plus GitHub sites, but in critical and really want using industrial. I think that the misunderstanding that they have is that when you have that software and the software is not disaggregated from the hardware, what they don't understand is that there is open source in that. The problem is that there is no digital bill of materials that is actually allowing them to know what it is they're doing. So they're actually, they are basing their reaction on a misunderstanding about their. And I think that until they actually can get underneath and see what it is, they are they're going to be they're going to be the misunderstanding at its core. So within the Linux Foundation, whether it's the Core Infrastructure Initiative or the Civil Infrastructure Project, Linux, or even it's being done in CNCF, we are embedded in the Linux Foundation in all critical infrastructure. You know, probably Linux, they're open source. What they don't have is model for being actually run software supply chain. So that's one thing. The second thing is I think that it's really critical that people start working in community. And I would say that about your project as well. It's like put the project into a community, build a community around it, and community be tested over and over and over again. The reason why the Linux Foundation was founded was because the Hitachis, the Fujitsus, the Mitsubishis, eventually the Facebooks, the Microsofts, the Google, all needed to, they were basing their businesses on open source, and they needed it to be in a safe, neutral place. So taking something of the dark web, run your structure is not an option. We need instead is to have safe supply chains. And you go to our website and you go to our wiki, and I'll see if I can find it and pop it in. There's so much resources available around how to build an open source program office and how to build an open source strategy. And I would just basically say to them, you're not going to get to the future on proprietary software. It's not happening, and it's not safe as well.
Yeah, thank you, Shuli. Yeah, sometimes I have a conversation with someone from MariaDB. This is one of the database software that's open source too. And I asked him, how can you maintain an open source to be secure? So there is not a malintention people to make there. And he said something like, there are millions of eyes looking at this code. So it's really difficult just to get a malicious thing there because there's millions of people that can look for that. But if there is I think it's not open, so it's easier to have more malicious things because nobody is seeing what is inside. So it's very interesting. For Simon, yeah.
Let me just say, which is that it's also a maturity. It's a scout maturity. I'm a big believer in the competency maturity model from Carnegie Mellon. And, you know, the ability to execute a complex vision without proper levels of maturity is just going to lead to failure. And in that way, you know, what I see happening in LF Energy and what, you know, I've been just really, really focused on is building a community of architects and managers of software maintainers and committers who are evolving, you know, in their maturity. All projects are getting badged with the Core Infrastructure Initiative, which is really a series of processes that are related to security. And we're also doing code scanning so that everybody knows exactly what is in the software bill of materials. And that until we actually get to an inventory everything where there is a software bill of materials that comes with software, we are not safe. And but it is a maturity process, and that's why community is important.
I would like us to give an interesting counterexample, which is, you know, one of the main first steps in going smart grid is always mentioned to be smart meters. And there is something people hate are smart meters. And why? Because you get a box at home with a closed software that does some magic calculation that you don't know, and you get a bill. And if you read online, when people think may happen in that box, you can have a lot of fun, including connection between smart meter and terrorism. If the algorithm calculating your bill were transparent, people will be much better off in believing in smart metering. I mean, at the end, every time you have something close, you build suspects around, and in building something that has to be for the citizen, this is definitely wrong. And smart meter is a fantastic example. In many countries, they just stopped the deployment because people were totally against. And that has been an extremely slow process in Europe compared to what was the expectation, because the customer didn't want it, because a strange machine charged me.
Just very interesting. That point of view, because one of the things is the technology that we think is gonna get into the community easier, but when it just crash with the community, we see another reaction. That's interesting. But it's true, the open, when there's something close, probably you think there is something inside that you don't want to see. So it's open, probably even if you don't see inside, you would think it's clear for everyone. Finally, we have just few minutes to end these, but I would like to thank all of you. And I'm really glad on your presentation that you mentioned that the isolation is not a way to get into anything. So we need collaboration, even for data, for software, for develop new things in the world. So there is something that is very interesting that Simon mentioned about the FAIR. So that you can find things, so find the data. I think it is very interesting because before we have internet, it was really difficult just to find even an article, a paper, and even to have access to that. And even that we are having right now, this internet, we still have a lot of issues finding stuff, even for open source. So even the GitHub is a really nice platform. It's quite difficult to find something right now. So I just want to ask you about how can we just make things easier to find, make things just easy to be indexed and to find, and to people can just get empowered of that and make it useful. You know? So there is the open source in the GitHub, but no one sees it is like no data there. And the same way for the data. So I don't know if you can elaborate more for this about finding the things.
So management, I didn't really come to, I mean, I came to this in a different sort of way than a lot of folks. Just popped in the LFN. So we're running this like an open source project. We agree with you. We need to have a place where you can, you know, I can show you this. That probably might be easier. Let's see. So, you know, what we did was we took the taxonomy that we were, and then we began to lay in, you know, the software, and each piece of software has a card, and within that card, the areas where the website is, you know, you can kind of see what's inside, how many commits are happening, and we believe that that this is partly what is going to drive a software community. So I agree with you. I think the taxonomy is really cool, and you guys will come and take a look at this. And you can add your own code. You know, CIM application or 9 code. This is not ours. So you know, it's not LF. But what we want is out there and make it visible, both open and also proprietary.
Thank you, Shuli. Simon.
So I'd add to that. Yeah, findable, discovery, etc. is a challenge, and you know it's the challenge, among others, of the internet age. A lot is said about the way that machine learning and intelligent search can help, and there are solutions there. But ultimately, I remain something of a traditionalist on this, and we need metadata. And understanding that in this digital age, if you want your stuff to be found, and if you want to be able to find stuff, then we need community-agreed standards of metadata. The taxonomies and the terminologies which have been mentioned are really important. Finding ways to apply those to the objects, whether that's code, whether it's data, in a more automated way, obviously that will make everyone's life better. But we need to get over that hurdle, add metadata to stuff so it can be discovered. And the other thing is that you know, one of the things that I mentioned briefly in my presentation that we're looking at is a metadata profile called CDI, which has been explicitly designed to assist with machine processing of data sets, a combination of data sets. And one of the things that profile does, which I think is incredibly interesting, is it attaches a lot of information to particular datum, because that's what people are often looking for. I need to have measurements of this particular unit value. I need to be able to search for those. Not at the high level for the data set. I need to be able to find data sets that actually contain measurements for, you know, whatever it is I'm interested in, but measurements for that unit value. So, you know, that enriched metadata is really important. Then being able to extract that and process that in your system with other things. It's one of the things that the Fair Data Principles aims to facilitate.
Okay, thank you very much. So, Shuli, Antonello, and Simon, I would like to thank you for being here to accept this discussion about this. For me, it's very interesting, this subject. Always have been looking, what about open source and open data, and always think what we can do with that. And you just open our minds a lot with this, and I hope all the people that just came here and the people that can see this and in the future can just think about this. So what we can do with the open things, open data, open source, and all the things that probably when they're public, they are more interesting than they do when they are closed. So it's like to be in a club. When it's a club, just the people who is inside can enjoy it. But when it is something public, you can everyone can enjoy that. So I think it would be a nice thing. So thank you very much. I'm really, really glad that you've been here. Thank you.
Thank you, Ernesto. I'd like to add a comment to what Shuli said about how wonderful this is to have these. We've had this explosion of Zoom meetings. Sometimes there are too many. Sometimes it stretches the working day. But for sure, it's incredibly exciting to be able to talk to people from all over the world, and in this instance, in Colombia. So muchas gracias todos.
Really look forward. So please reach out. Let's talk about what you're working on, and let's keep the conversation going. Sometimes I feel like my life is all about weaving things together, and I often start my day in Europe and I end my day in Australia and India, and what I'd like to be able to do is to also have you all in my day and to be working and building something together. So,
okay. Thank you. Yes, we do. Thank you very much. Thank you, everybody who attended this presentation.
thank you.
Bye.
Thank you.
Bye.